Hello, everyone. My name is Hao Yuan, the PhD in University of Virginia. Today, I will present the paper Multi-Agent Reinforcement Learning based distributed renewable energy matching for data centers. So with the rapid growth of the web application and the cloud computing, more and more web application deployment are based on the cloud services and require an enormous amount of energy. The estimation in 2018 shows that the worldwide data centers consume around 1% total electricity used worldwide. At the same time, the total volume of carbon emission will be 1,430 million tons, and the data center is responsible for 18% carbon emission in the world by 2020. The huge amount of brown energy consumption and also the carbon emission risks global temperature and other negative environmental effects. In order to mitigate the adverse environment impact and the energy crisis caused by the rapidly increased brown energy consumption, many companies have started to power their data centers using the renewable energy as much as possible. For example, the Apple built an 40 megawatts solar array for its data center. However, a data center cannot always use the renewable energy generators to satisfy its energy demand because of the variant amount of renewable energy from the renewable energy generators. Therefore, the shortage of renewable energy supply may lead to the violation of the job service level objectives, such as a percentage of the requests or jobs from a customer that can be served or completed before the job deadline. So the large amount of, in practice, a large amount of renewable energy generators and data centers can be widely distributed in a very large area, which may belong to different cloud service providers. Therefore, it is important for one data center to determine the amount of renewable energy to purchase to satisfy its jobs the energy consumption to avoid the SLO violation. According to this, we have the question below that for multiple data centers and multiple renewable energy generator and they are widely distributed in a large area, how should the renewable energy generators be matched to different data centers in order to fulfill their energy demand in the long term, to minimize application SLO violation rate and the total carbon emission monetary cost of each data center. Here is the related work, and the renewable energy to support data centers problem has been investigated in recent years. We classify the previous research works into several features, and our method can handle all these features, including we can handle the multiple data centers, the constraint by fixed matching, the carbon emission consideration, the monetary cost consideration, consider the SLO violation or satisfaction rate, and also it is for multiple CSP, so cloud service providers. So here is an overview of our ML-based system. We first present the method for this to predict its own energy demand and the amount of the generated renewable energy of each renewable energy generator at each time slot in the next time period, which is the energy prediction squared in the figure. Then we formulated this energy generator, renewable energy generator, and the data center matching problem into a markup game. And we use multiple agent reinforcement learning to solve this problem. First of all, the prediction method, as shown in the above figure, our prediction method instead sets a gap period between the input data points and the first output data point. The input data is a historical time series data of the amount of generators generated at renewable energy, or data centers demand, and the output data is a series of corresponding predicted values. Both energy generation prediction and energy demand prediction will use the prediction method to make sure that there is enough time left for the data center to make data center generator matching plans, and also to make sure the execution of the matching plan. The following four figures shows the prediction accuracy results for different renewable energy. And we compared the three different machine learning techniques, SVM, ASRSTM, and SARAMA. We find that SARAMA can always get the best performance in all the figures. Within the problem formulation, the state space, there are 3 points we need to point out. The first thing is state space. It includes the information of all the renewable energy generators and the data center of the agent, like the predicted, the generated energy, the amount of generated energy, and the energy demand. The action space shows the reinforcement learning agent, and the data center makes decisions space only for this data center. It includes how much energy this data center should be requested from each renewable energy generator. For the reward function, we consider the monetary cost, the carbon emission, and the SL violation rate with different weights, and all of these weights can be set manually. Within the MARL, we use the minimax Q-learning in MARL to determine the Q-value updated mechanism. The next is the performance evaluation. We have the workload generation. It's generated from 30 million Wikipedia web pages in one data center, and we consider one request as one job. And the experiment scale is from 30 to 150 data centers and the 60 renewable energy generators. The energy trace is from the actually the temperature information from Virginia, Arizona, and California, including the solar data and the wind data. For the comparison method, we have 4, and the first, the GS, it tends to run more jobs when the energy supply is higher. In GS, the data center uses FFT to predict the amount of generated energy at each time slot in the next month, and send its demand to the generator with the highest predicted generated energy amount. The REM, the second one, aims to minimize the monetary cost of energy. REM is similar as the above method, except that one data center uses our method for prediction and chooses the generator with the lowest average unit price over 1 month to request first in order to minimize the monetary cost. And we added the prediction method just to make sure the fairness between all the comparison methods. The REA 31 is same as the GS, except that when the data center does not receive sufficient renewable energy, it uses the reinforcement learning to determine which jobs need to be postponed to the next time slot in every hour. In SARL, each data center uses STM machine learning technique to predict the amount of each generator's renewable energy, generated renewable energy, and uses our reinforcement learning to determine the amount of energy requested from one data center to which energy generation or to minimize the monetary cost and the carbon emission with lower SLO violation. However, since there is competition among all the data centers for energy requests, and the traditional single reinforcement learning may not be able to receive belongs to the different data center, may not be able to achieve its goals easily, and they may need several times to achieve enough energy so that the energy price will be increased. So next is the performance evaluation results, and they all in the SL satisfaction ratio, monetary cost, carbon emission. They all show that our method MIL can achieve the best performance, and the detailed explanation, please refer to our paper. So here is a conclusion. We first compared the prediction accuracy of several machine learning techniques using real data sets and choose SARMA that can achieve the highest accuracy in our method. Based on the predicted renewable energy supply and the energy demand, each data center uses MARL to determine how much renewable energy to request from each generator and achieve the goals in the problem above. We conduct a comprehensive real trace-driven experiment to compare our method with other 3 methods, and the experiment results show that our method can achieve a much lower SL violation rate, total energy monetary cost, and total carbon emission compared to the other methods. For the future work in the future, we will investigate how to jointly conduct a workload balance, considering the job computing resource competition, and how to distribute the generated energy to data center requesters. Thank you very much. Feel free to ask me any questions or just drop me an email. Thank you.